Welcome parents and students alike. This week we will be reviewing for the Unit 7 test, and we're reviewing in class, and also I'm sending home some practice pages which will really help them on the test on Friday. So first question, select the way that shows the shaded, underlined shaded fraction. Mark all that apply. So there could be 2 or 3 answers. Mark all that apply. So first of all, we've been studying fraction strips and fraction bars. This is a fraction bar, and as you could see, the first thing we do is establish how many sections there are on this fraction bar. I see there's 1, 2, and 3. So that's our denominator, because that's the whole. That represents the total number of sections. And then the shaded part, which is the part of the whole, the shaded, I see that there's 2. So right away I could see B is true, 2/3. 1/3 represents the unshaded part, so that's not a good answer. 3/2 is totally wrong. 3/2 is more than 1. And then what about 1/3 plus 1/3? Yes, that's what we call the sum of the unit fractions. So this is 1/3. This first part is 1/3 of the whole, and this is also 1/3. If we add 1/3 plus 1/3, we get 2/3. So this one is true as well. 3 ones, that's just a distractor. All right, number 2, what unit fraction of the whole shape is the shaded triangle? Again, we're looking for the shaded triangle. We notice all of these are unit fractions. All right, that's the smallest part of the whole. And it always has a 1 as a numerator, unit fraction. Okay, again, we're looking for the shaded triangle. We see that there's 2 altogether, and 1 of them is shaded. So this is 1/2. We see there's 1, 2, 3, 4 total, and 1 is shaded. So 1/4 straight across. 1, 2, 3, and 1 is shaded. And then let's start with the shaded part. 1, 2, 3, 4, 5, 6. These are in sixths, and we see 1 of them is shaded. So it's way up on top, 1/6. All right, let's look at the other side of your paper. Use the fractions to label each point on the number line. So we're going to use these fractions. We're not going to use them all because there's only 4 boxes and there's 6 in the bank. So we're going to pick 4 out of the 6. All right, so let's see how this is organized. We notice that here's 1 hole and here's 2 holes. And we know that 1 hole is when the numerator and the denominator are the same. And we see that is 1 hole. All right, it looks like this is halfway between 0 and 1. So that would be 1/2. It could also be 2/4 or 4/8, but they'll be pretty happy to see this as a possibility because it's pretty obvious that this is 1/2, halfway between 0 and 1. All right, so now these are greater than 1. So what we need to do is look at where the dot is. Here's the dot, here's another section, so we have to divide this into equal fractions. So it looks like there's another space here. So we have 1, 2, 3, 4. So from 1 to 2, this is divided into fourths. So this is a fourth. And which one is it? This is 1 and 1/4. This is actually, sorry about that. I could see what they're going to do here. This is 5/4 because 1, remember, is 4/4 or 5/5. So after the 4/4 we have 5/4, 6/4, 7/4, and then 8/4 is the same as 2. You notice the pattern here that the numerator is twice as big as the denominator. So when this is called a improper fraction. Numerator is bigger than the denominator, so it's greater than 1. So it's 8/4. So number 2. Wow. We don't have 8/4. So if this, the answer is 10/5. Okay. Boy, that's going to really throw them off. So it's really on 2 different number lines, and they're mixing denominators, you could see, on the same number line. But again, the pattern is if the numerator is twice as big as the denominator, then it's 2, because 10 divided by 5 is 2. There's 10 pieces in a pie. That's here's the pie, and it's divided up into fifths. Okay, it's divided into 1, 2, 3, 4, 5 into fifths. Here's one pie, here's another pie, and if we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 pieces, and they're divided up into fifths. So 2 pies is the same as 10/5. So that's 10/5. Let's go back here. That's 7/4, because we divided this into 1. We saw there was a gap here. How did we do that? We saw there was a gap, and so we continue. We just divide this into half. Just like this is half of this. This is half of 1 and 2. And then we continue. This is 4/4, and this is 4/4 and 5/5. This would be 6/5. This is 7/5, 8/5. This is, I'm marking the fifths where the fourths are. So that really messes, we really can't draw fifths and the fourths together. It just creates a whole mess. We have to draw a separate number line. We just have to remember that whenever it's 2, the number is 2 wholes, like 2 whole pies, then the number on top has to be twice as big as the number on the bottom. So 10 is twice as big as 5. 10 pieces that are divided into fifths. And I drew it right here. All right, sorry for the confusion. Select the fraction that would be included in an equivalent chain of 1/4. Mark all that apply. All right, so 1/4, definitely not this, because this equals 1 whole. Again, if we want to reduce this to fourths, what do you have to do to 8 to make it a 4? We divide by 2. 8 divided by 2 is 4. 2 divided by 2 is 1. So this is an equivalent fraction of 1/4. This is not. This is actually equal to 3 wholes, because it's 3 times bigger than that. And then let's see, if we divide this by 3 over 3, 3 divided by 3 equals 1, 12 divided by 3 equals 4. So these two are equivalent to 1/4. Choose the symbol that completes the comparison. All right, what's bigger, 7 halves or 7 thirds? So just like in a unit fraction, you know, if this was 1/2 and this was 1/3, in when we compare unit fractions, we know that the numerators are the same, so the smaller, relatively smaller number is a bigger fraction. So if the numerators are the same, that means there's the same number of slices in a pie. This one, the half, is sliced up into a bigger portion. So this is bigger. 7 halves is bigger than 7 thirds. You can see that this is a half, and this is a third. You could see that a half is bigger than 1/3. How did you know which symbol to choose? Okay, I know 1/2 is larger than 1/3, so 7 halves must be greater than 7 thirds. All right, and a lot of students like to do it this way, 7 halves. We compare 7 halves and 7 thirds. So we cross multiply. 7 times 3 is 21. 7 times 2 is 14. 21 is greater than 14, therefore 7 halves is greater than 7 thirds.